Welcome back to my channel. So in today's tutorial we are going to solve a question. In fact, it is a quiz question for one of the groups, that is group 9. So this is the fourth quiz of group 9. So this question is from quiz 4 of group 9, the first question in that quiz. So that's what we are going to be doing in this tutorial. So the question is, using the method of mathematical induction, prove that n to the power 5 minus n is divisible by 5 for any integer n greater than 1. Okay, so let me divide my screen to partitions so that we can use the partitions. So here our solution is, so first let p of n is such that n to the power 5 minus n is divisible by 5. So that means it's equal to 5 times maybe an integer a, so where n and a belongs to what? Integers, a set of integers, and n is greater than 1. Okay, so this is the first step. We have to state our proposition in a declarative sentence. So the next step is to prove the base case. So our base case, so the next integer, we know that one is exclusive, so the next integer is 2. So let at n is equal to 2, so we have 2 to the power 5 minus 2. So let's see whether this is divisible by 5. So this is equal to 30, and we know that 5 divides what? 30. So 5 divides 30. So 30 divided by 5 gives us 6. So 5 divides 30. So our base case is true. So since this is true, so since the base case is true, we assume that, so this is our hypothesis now, induction hypothesis. So this is our hypothesis. So we are going to assume that p of k is true. So implies k to the power 5 minus some integers, or minus k gives us 5 times b, so 5b, where b is in the set of integers, so something like that. So at n is equal to, at n is equal to, let me rewrite this, at n is equal to k plus 1. So this is the induction proof now. We now have k plus 1 all to the power 5 minus k plus 1 in bracket. Negative is affecting both k and 1. Okay, so this is what we are going to expand. So we are going to see whether this will give us some integer which is a multiple of 5. Okay, so if you will permit me to do some cancellations so that I can be left with only this, so that I can do the expansion well, because this needs more space to expand. So let me just cancel everything so that I'll have only this k plus 1 to the power 5 minus k plus 1. So this is equal to, so if we were to use, so here we'll use two methods. First we'll use the binomial expansion, then the next one we will have to factor k plus 1 out and use the factorization to expand. So factorization and expansion. So this is our second method. Okay, let me just cancel. Alright, so we have our k plus 1 all to the power 5 minus k plus 1. So if we are to use the binomial expansion, so I think the Pascal triangle will just give us some simple distance. We have 1, if we start from 1, then the next, this is to the power 0, so 1, the next one will be 1 1, this to the power 1, 1 2 1, this to the power 2, 1 3 3 1, this to the power 3, 1 4 6 4 1, this to the power 4, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 5 1, this to the power 5. So we just need this, and we know that the powers of k will be decreasing. The power of 1 is what will be what increasing. So here we're gonna have k to the power 5 multiplying 1 to the power 0, k to the power 4, it will be decreasing, multiplying 1 to the power 1 will be increasing. You realize that 1 will remain 1, it will have no effect on this because 1 is the identity element of multiplication. 1 times any number is that number, so we can just get 1 out of the expansion. So we just have k to the power 5 plus 5k to the power 4 plus, so I just expanding this without the negative, so plus 10. You know that the exponents or the powers of k will be reducing to the power 3 plus 10k to the power 2 plus 5k to the power 1, so it's not necessary, plus 1. Okay, so we've just expanded this. So in place of k plus 1, to the power 5, we are now writing this. So let me have it here. So here we now know that k plus 1 to the power 5 is what? K to the power 5 plus 5k to the power 4 plus 10k to the power 3 plus 10k to the power 2 plus 5k plus 1 minus k minus 1. You realize that this positive one will go away with this, so we will now have this to be what? K to the power 5 plus 5k to the power 4. Let me cancel this, I have it already. So okay, so we are continuing. K to the power 4 plus 10k to the power 3 plus 10k square plus 5k minus k. From our induction hypothesis, we have that k to the power 5 minus k is equal to what? Some 5 multiplying b. I believe you can still remember this. Here we can make k to the power 5 the subject to be what? 5b plus some plus k if we bring k to the other side. So here, if we don't want to write k to the power 5, we can just write this 5b plus k plus 5k to the power 4 plus 10k to the power 3 plus 10k to the power 2 plus 5k minus k give us what? 4. Oh, sorry, instead of k I'm writing b. Okay, we have 5b. I think these are the only like terms, so we just have to group them and add it, giving us 5k again. So we have plus 5k to the power 4 plus 10k to the power 3 plus 10k to the power 2 plus 5k. You can see that 5 is common throughout, so you can see it. And since 5 is common throughout, okay, we can factor the 5 out, leaving 5 multiplying b plus k to the power 4 plus 2k to the power 3 plus 2k square plus k. So this is giving us some 5d, where d is equal to all this, b plus k to the power 4 plus 2k to the power 3 plus 2k square plus k. So it's in what? A set of integers. So we can see that k plus 1 all to the power 5 minus k plus let me cancel this part, minus in bracket k plus 1 is also giving us some 5 multiplying another integer d. So this is telling us that p of k implies p of k plus 1, and since p of k implies p of k plus 1, it is telling us that the proposition is also true. So we can conclude that that n to the power 5 minus n is divisible by 5. So n to the power 5 minus n is equal to some integer terms. So but your conclusion should be maybe a, we already assume it somewhere. Your conclusion should be hence, since p of k implies p of k plus 1, then n to the power 5 minus n is divisible by 5 for any integer n greater than 1. And I will even say that it is true for all integers. I will argue that this is true for what? All integers, because in fact if we put 1 to the as our n, 1 to the power 5 minus 1 gives us 0, and 0 is divisible by 5. If we put negative 1 there, we have negative 1 minus negative 1 to the power 5. This still gives us negative 1. Negative 1 minus negative 1 gives us 0, and 0 is divisible by 5. If we even substitute, let's say negative 10, or negative 10 is a big number, let me use negative 2. Negative 2 to the power 5 minus negative 2 This gives us negative 32 plus 2, which is negative 30, and negative 30 is divisible by 5. So this is true for all integers, but we just conclude it using the proposition given to us in the question. So you don't say it's true for all integers as your conclusion if that was the question, but this one is not the proposition given to us in the question. So we conclude using the proposition given to us in the question. So that is it for the first method, binomials. I think that is the easiest way to think of solving this question. Okay, so the next method is to what? Factorize and what? Expand. So I'm just continuing with my k plus 1 to the power 5 minus k plus 1. This is equal to, we factor, you can see that k plus 1 is what? Is common with the 2 times. You can see that k plus 1 is common, so we just factor k plus 1 out, so that here we can now have k plus 1 all to the power 4 minus 1, and this is just like k plus 1 all to the power 4 minus 1 square. So you can see that this is difference of 2 squares. This k plus 1 square all square minus 1 square. So this is a square and this is also a square. So this, we can use the difference of 2 squares. We know that a square minus b square is equal to a plus b a plus b a minus b. So we just apply it here. This gives us what? K plus 1. Then in the bracket we'll have k plus 1 square plus 1 multiplying k plus 1 square minus 1. Okay, so this is equal to, so I just keep my k plus 1 here, then inside the bracket I start with my expansion. This gives me 2k, k square plus 2k plus 1 square is 1, 1 plus 1 is 2, multiplying k square plus 2k plus 1 square is 1, 1 minus 1 is 0, so I don't even need the plus. So as you can see from here, inside the bracket we can expand. So we continue with our expansion, k plus 1. So we just distribute this k square with all this. So k square times k square gives us k to the power 4 plus k square times 2k gives us what? 2k to the power 3. So we are done with okay, k square times 2 gives us 2k square. Okay, so we are done with k square. So we drop k square and pick 2k. 2k times k square gives us 2k to the power 3 plus 2k times 2k gives, so 2k and what? 2k gives us what? 4k to the power 2 plus 2k times 2 gives us 4k, and we are done. So we still keep our k plus 1 here. Then here we have k to the power 4. I think it's only 1. I have 2k to the power 3 here, 2k to the power 3 here, giving us what? 4k to the power 3 plus 2k square 4k square given as 6k square plus I think that is all. 2k to the power 3, 2k to the power 3, 2k square, this is 4k square. Okay, plus I left it one time. Okay, 4k. I think that is it. Okay, so we will now distribute k to all this and 1 to all that. So let's take k, and this will be easier. K multiplying this gives us k to the power 5. K with 4k gives us 4k to the power 3 plus k with gives us 4k to the power 4 plus k with 6k square gives us 6k to the power 3 plus k with 4k gives us what? 4k square. Okay, we take 1 times any number is that number, so we just repeat what is in the bracket. So plus k to the power 4 plus 4k to the power 3 plus 6k square plus 4k. So we just look for like times this k to the power 5 is only 1 plus, so we just look for like times 4k to the power 4 here. We have k to the power 4 here, so this gives us 5k to the power 4. 6k to the power 3, we have 4k to the power 3 here. This gives us 10k to the power 3 plus we have 4k to the power 2, 6k to the power 2. This gives us 10k to the power 2 plus we have 4k here, only 4k. But from our induction hypothesis, we know that k to the power 5 minus k gives us what? 5. Some 5 multiplying maybe a or b. Okay, 5 multiplying b. So k to the power 5, making k to the power 5 the side, we have 5b plus k. You see, so we can bring it here. So some 5b. Okay, so in place of k to the power 5, we can write 5b plus k. If you agree with me, I will just keep the k and add it to the 4. So let me just bring it here. My space is not all that enough, so I'm just adding it. So I'm removing this. I'm just writing 5b plus k in place of the what? K to the power 5. So that here I'll have my 5b plus, I'm keeping the k and I will add this k to the 4k here to get another 5k. So you see that all we just maintain this, the difference or the impact is just on the k, this 4k. That will be the only term to be increased. So among all the terms, all the terms will remain unchanged with the exception of 4k, which will be increased by k. So plus 10k to the power 3 plus 10k square plus, you see those I've circled, k is here, 4k is there, so we now have k plus 4k giving us 5k. So all of this, you can see that 5 is common throughout. You can see 5 throughout. 5 here, so 5b plus 5k to the power 4 plus 10k to the power 3 plus 10k squared plus 5k. So you can factor the 5 out. Let me cancel the first step. Let me cancel this. So this one, you need a lot of expansions, and with a little bit of mistake you will be choked. So you have to be careful when expanding or factorizing. So here we now have our k plus 1 all to the power 5 minus k plus 1, giving us 5 out, b plus k to the power 4 plus 2k to the power 3 plus 2k to the power 2 plus k, and this is equal to some 5 multiplying d, where d is equal to k to the power 4, sorry, b plus k to the power 4 plus 2k to the power 3 plus 2k squared plus k is in what? Integers. So it's here you can do your conclusion, and I believe you can all do the conclusion perfectly. So you just conclude, just take here. So since p of k, since our p of k implies p of k plus 1, then or hence n to the power 5 minus n is divisible by 5 for any integer n greater than 1. That's your conclusion. And I further argue that this is true for all integers. I've shown it with 0 to, you can check it, 0 to, you can check it, 0 to the power 5 is 0 minus 0, 0 is divisible by 5. And that is it for today. Thank you all for your attention. If you find this helpful, please do subscribe to my channel and like this video. Thank you very much.